Okay, so we have gone ahead and we've started up today's stream. So I'm just going to open up my sort of lesson plan. Perfect. Hey, Maria, how are you doing? And I'll give it a couple more minutes for everyone to sort of join and whatnot. I'm good. I'm good. You may notice that the whole camera and everything is sort of different. My audio might even sound a little bit different. Um, I'm actually on vacation right now, so I'm just trying to figure everything out and keep it as, seamless as possible. That's why our last lesson, lesson 4, was actually a recorded lesson. So I'm glad I got the opportunity to, however, make this live though, because I definitely prefer doing like streams to like recording. It's a lot more fun for me at least. Okay, so I'm gonna give it another minute or so, maybe a minute or two, and then we can go ahead and get started with lesson 5. Okay, yeah, let's just go ahead and get started. So today's lesson, lesson 5, it's going to be an hour and 30 minutes long. So that's 12 p.m. EST to 1:30. So before I go ahead and get started with today's lesson and we start reviewing all the stuff from lesson 4, I want to ask if anyone has any questions from what we did in the previous lesson, because I know that was a recorded lesson and I wasn't there to sort of answer any questions if anyone had them. Does anyone have any sort of questions from what we did in lesson 4? I missed the last session. Yeah, that's fine. The last session was a recorded session. It wasn't live. And honestly, it was pretty straightforward. We just did a little bit of those loops again. And we touched upon something called a function. And again, when I do my review, which will probably take up the majority of the class anyway, you'll be able to sort of like, get with what we're doing. And of course, if you just still don't understand, I do recommend you take a look at lesson 4, just for like clarity and all that stuff. So if there's no questions, let's go ahead and yeah, let's just start with like a review of what last lesson was talking about. So the main idea of the last lesson was to talk about functions, and we did a practice with our loops. So with the loop practice that we did, so we had loop practice. Um, the first thing we talked about was, we had our for loops, right? So we had our for I in range, whatever, our colon, and then we indented in, and we could do whatever we wanted to with this sort of I variable that the for loop created. And one of the things I wanted to do in our last lesson was actually get some practice with this whole idea of the start, the step, or sorry, the start, the stop, and the step, right? Because those are the three main things that sort of define um, how this range loop creates our for loop. So just as a little bit of a review, when we create our for loop, right, our range only really requires one uh, one sort of argument, right? It only requires you to tell it when to stop. And so if I wanted to print out all the numbers from 0 to 100, right, I would say for I in range 101, because that stop is not included in your for loop. So once I go ahead and run that, you'll see that I'm printing everything from 0 to 100. And so I'm starting at 100, right? But I'm not making that explicit. I'm not stating that within my code. The only thing that I'm stating with my code is that this thing needs to end at 100, which is something that I've stated here. And just as a sort of, what the range does is it goes up to, but doesn't include that last sort of number. And if there are any sort of audio or like visual, like it's just like not working, just let me know because I am on hotel Wi-Fi, so you guys know how that is. So yeah, when we don't have to, we don't have to give it that start and we don't have to give it that step. And when we don't give it that step, you can see that everything is incrementing by one. We're going up by one every time. So our step is one. That's sort of like a default thing already there. So again, main takeaway from what I'm saying is from all of this, all you really need to state when you call that range function is your stop value. All right. So then how do we then use our, how do we implement, our start and our step? So with, let's say I want to print all the numbers from 50 to 100, right? At that point, I would have to specify what my starting value is, right? Because I'm not starting from zero. I'm not starting from this default value. So to do that, what I would have to state is I would have to come before my stop, right? Because it's start, stop, and then step. And I would put 50. If I ran that after I clear the console, you can see I'm printing all of the numbers from 50 to 100. And you might be saying, why am I not stating, 49 or 51 for this? Since this is your starting point, it's sort of like you have your starting point, then you have your ending point, and you go all the way through there. So that's why your starting point is included within all the values in the for loop. So cool, we have our start and now we have our step. The next thing we want to see is how do we build in, or sorry, we have our start and our stop. The next thing we want to see is how do we implement our step, right? So right now I'm incrementing by values of 1, right? 50 plus 1 is 51. 51 plus 1 is 52. So how do I, say for example, print all the even numbers from 50 to 100? Well, we know that the even numbers are like 2, 4, 6, 8, 10, 12. And with that, we can see that we're incrementing, right? We're stepping up by value of 2 every time. So to do that, I would come here and I'd put 2. If I run that, I see I actually need to clear the output. If I run that, then I see 50, 52, 54. So we're starting at 50, right? We're ending at 100, right? And as we go from 50 to 100, we're jumping by 2 every time. We're not counting by 1. We're going 50, 52, 54, 56, 58, so on and so forth. So one of the practice things that we did with our for loops is we actually did something to print out the first 10 numbers backwards. Right? So let's go ahead. Let's do what we know. What we know is how to create that sort of skeleton of our for loop. So we have a for I or for num. It doesn't really matter. As I stated before, I is sort of like what everyone uses for things like this. So we have for I in range, okay? And then, oh, sorry, for I in range, have that colon, we're going to print out our I, okay? So now we have to sort of understand what is our start going to be, what is our stop going to be, and what is our step, right? Okay, so first 10 numbers backwards. So that's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? And if I write that out, 10, 9, 8, 7, 6, 5, and so on and so forth. And we're going to go all the way to 0, right? Actually, we're going to go all the way to 1. That's the first 10 numbers. So we can see that we're going down 1 every single time. So we're sort of starting at 10. We're going up until 0, right? Because that 0 is not included. We're going up until that 0. And as we go from 10 to 0, we're subtracting by 1 every time. And when you look at it like that, um, you can then sort of figure out what your start, your stop, and your step would be in that case, right? So I'm starting at 10. I stop. Well, I'm going to 1. So if I'm going to 1, I want that 1 to be included, right? That means I'm technically going all the way up to 0, but I'm not including my 0. That's sort of the way that you have to think about it when you're trying to figure out your stop value. So I have 10 to 0, okay? And as I go from 10 to all the values up to, but not including 0, I'm stepping by -1, right? I'm subtracting 1 every single time. If I do that, I do subtract 1 or -1. Um, and if I clear my output and run this, you can see we're going 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So, is everyone okay with that? That's sort of our our practice, or at least the practice that we did with the for loops. And I'll give anyone who needs it some time to just like catch up or whatever. Maria asks, why the -1? Right. So again, that's our step, right? So we understand that our start and I'm sure our start and our stop makes sense, but our step is probably what might be a little dodgy, and that makes sense. So let's think about what we want, or what are we trying to accomplish here, right? We're having our code go from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? And we're starting here at our 10, right? Our 10. And every time we go through this loop, our value sort of decreases, right? By a value of 1. So I'm starting my I at 10. And as I go through this range of values that this range function generates for me, right? I need to ensure that the next number that comes after the 10, right? It has to be a 9. So how do I go from 10 to 9? Well, I do that by subtracting 1. And then I keep subtracting that 1 up until I get to that, up to but not including 0 sort of thing. So that's how you have to think about your step. How am I moving from each number to the next? So cool. That was the loop practice that we did um, in our last lesson. We also did a little bit more practice with our while loops. So we had our while loops, right? And if you remember correctly, a while loop runs as long as the expression we give it evaluates to being true, right? With our for loop, it ran as long as we told it to run, or as long as we specified that range function. But our while loop will just keep going as long as whatever it evaluates comes out to being true. And that sort of gives way to the idea of there being, infinite loops, right? Because if your expression keeps evaluating to be true, then you get that infinite loop. So what did we make last class to practice our for loops? Well, we created a system that keeps accepting numbers from the user and then adds all those numbers up. How do we keep building this? We want to keep accepting numbers from the user and then adding all those numbers up. Well, we've done some things that are similar to this, right? When we add up all the numbers from 0 to 100, we got 5,050. So the first thing we did with that was actually created like this sort of variable. We called it sum or something like that. And essentially what this is meant to do is as the user gives us a number, right? So let's think about what this program is going to do. The program is going to ask me, hey, do you want to add a number to this huge collective sum? I'll say yes. It's going to say, what's that number? I'll say 10. That 10 will then get added into that sum. And then it'll ask me again, do you want to add another number? Yes. What number do you want to add? 35. It'll take that 35 and then it'll add that to that collective sum. So then you'll have 10 plus 35, so 45. So this sum is sort of like what we keep adding our numbers to so that it continues to increase. So we have that sum. The next thing we have to do is we have to ask the user, right? We have to say, hey, do you want to add a number to the sum, right? So we say user choice, right? Say input. Would you like to add another number? Mhm. And we'll just put like a Y or an N sort of thing here. Cool. And let's just make sure this works. we'll print out our user choice. Let's run this. If you'd like to add another number, y or n, y. That y stands for yes, the n stands for no, and that is working out just fine. So we're working with our input functions here. And if you remember correctly, the things that we give this input function, right? The input, or sorry, this sort of thing that we put within the parentheses of the input function, that ends up becoming the prompt that we get asked right here. The prompt that the computer asks us. So, would you like to add another number? Let's say they say yes. So the next thing we have to do is while, right? While our user's choice, I'll put that in the parentheses. So while our user's choice equal to yes, right? Equal to that y. Hi Flash says, I'm watching lesson 1 right now. That's awesome. I hope you enjoy. I hope it works out for you. And of course, feel free to join any of the streams and ask any questions about previous lessons. I'll be happy to, go back and pull up my lesson plans for them. Anyway, so while our user keeps saying yes, right? That's what this little expression right here is stating. So while our user says yes, we're going to then ask them for their number, right? User number is equal to input. What number would you like to add? Then they'll type in that number, right? And we know that our input function gives numbers to us, or actually returns things in the form of strings. So then in order to add this to our huge little collective sum right here, we then have to convert our string into our integer. And in order to do that, we have to use our handy dandy int function. And I'm just going to wrap it around right here, right? And again, I know I told you guys that you can wrap it, on the variable itself. You can wrap it later when you reference it, but I'm just going to wrap it right here just for the sake of keeping our code concise. So we then have, okay, let's go over what we've done. We asked the user, would they like to add a number to our sum? Let's assume that the user says yes. Okay, so now that the user has said yes, we're going to enter into this loop. And the first thing we're going to do in this loop is we're going to ask them, okay, you've said you want to answer, or sorry, you've said you want to enter a number. What will that number be, right? What number would you like to add? So we're going to take their input on that. And again, we know that that input, it gives us a string. In order to add it, it needs to be an integer. So we take that string and we convert it into an integer with our int function. So cool. Now we have the user's number stored to a variable as an integer. So what can we do now? We can take that number and then add it to our huge little sum. So we'll say sum plus or equals user number. What's going on here? I'm taking my sum variable, right? And I'm going to say, hey, this sum is basically what my old sum value was plus whatever my user number is. I'm going to take my value of sum that it currently is. I'm going to take the value it currently has. I'm going to add that user number together, right? I'm going to add them together, and I'm going to save it back to the sum variable again. So this is sort of how you can add values to variables. Cool. So now that we've done this, right? So let's think about what it does. Okay, what do you want to add a number? Yes. Okay. What number would you like to add? 10. Okay, 10 is added. And then we have to ask the user again if they would like to add another number. So we're actually going to copy this line of code right here, and we're going to paste it within the while loop. So this is within the while loop. Because the first time we run this, we'll enter this while loop, and we'll be in there up until our user says no. So that's why you have to sort of add this whole this user choice part underneath the while loop one more time. So let's try this out. Okay, and actually, wait, let's not try this out because there's no way to check it to see if it's working, because we need to make sure we print out that sum, right? So why am I printing it outside the while loop this time? Okay, so my user says yes right here, right? I then enter into this while loop, and I ask the user, what number would you like to add? They gave me a number, I add it. And then I ask again, Would you like to add another number? Let's assume this time that they say no, right? At that point, my user choice will then be n. It'll have that n value. It won't be y, right? It won't be y, it'll be n. So then when Python says, okay, now your user choice variable, it's equal to the string n, right? I'll put that in little, I'll comment that out right here. Right, that's what it'll be equal to if I say no. When it comes to check to see if the expression is still valid, checks to see if this whole thing should still run again, it's going to say, hey, is user choice equal to y? Is it equal to yes? It's going to say, hey, no, it's not. It's equal to n. And so then this expression will no longer be true. And because it's no longer true, then it's going to break out of this loop. And as we break out of this loop, then we can go ahead and print that total sort of collective sum that we have. So again, let's clear the output. Let us then run this. Would you like to add another number? I'll say y. Actually, I'll say n. The program should terminate, right? Our sum comes out to being 0 because we added nothing to it. If I try this again with a y, what number would you like to add? I'll say 10, right? Would you like to add another number? So this sort of second prompt is coming from within the while loop, right? It's this thing right here. So then if I say n to this, oops, we break out of that loop and we just print our sum, which is only 10, because 10 is the only number that I added. So now let's give this a go for a couple rounds. I'll say y, we'll say 10. Y again, we'll say 20. Y again, 30. And now I'm going to say n, and we should hopefully get 60. Perfect. That's our sort of little practice with our while loops. And earlier we did our practice with our for loops. Before we move on, does anyone have any questions with this? Because this is sort of like the big thing that I covered with lesson 3, I believe. Lesson 3 was loops, yeah. So any questions with what I've covered so far? Okay, so I'm not seeing any questions, but again, if something comes up, if I need to go back to this, I'll be happy to do so. So let's continue with our review of lesson 4. And again, I do apologize. I did not like having lesson 4 be a recorded video. I definitely prefer streaming. So the next thing we talked about in lesson 4 was a function. Function. I'm going to try to go over this a little bit faster because I don't want to be too redundant with what I talked about in the last lesson. So again, if you're not able to sort of follow along with this review, I do ask that you go back and check out lesson 4. Okay, so let's talk about what a function is. A function is sort of like a defined set of code, right? That runs over and over again. So it allows you to reuse a set of code over and over again. And so have we worked with functions before? We sure have. Let's think about some functions that we've used with. We've used our str functions. We've used our int functions, our float function, our input function. How do we know these things are functions? They all have the sort of same general anatomy into them, right? They have this name here, right? Because this is how we reference them. We call it the str function or the int function, the float function. That's their name. And then they have these parentheses. And in these parentheses, depending on the function, I could give it, a different input. I could give it 93. I could give it, string 15. I could give it a prompt to ask. So it's like all of these functions have the ability to take in input, right? We're able to give them things. And every time we give them something, they give us a response back that's different, right? Because if I do, let's say I have the int of the string 15, and then I have the int of the string 19. I'm giving them different inputs, and they yield me a different output, right? This gives me the integer 15. This gives me the integer 19. So it's the same block of code, but every time I give it a different input, it gives me a different output. So those are functions that we've worked with, and Python also allows us to create our own functions. So let's go over how we can define a function. The first sort of thing with defining a function is this def keyword. You notice that in Python, we have a bunch of keywords. We have if, while, for. Def is the keyword that you use when you're creating a function. And what does this def stand for? Usually when we have stuff in Python, it sort of is shorthand for different things. So if you remember, when we had our elif, right, that stood for else if. So this def, pretty straightforward. It just stands for define. So we have defined a variable, right? We're going to def something. The next thing you want to do is give your function a name. So for the sake of this example, I'm just going to call this print name. That's what our function is going to do. It's just going to print my name out to the console. So let's read what we've done. Define a function called print name. That's what this sort of thing is reading out to if you're looking at it in plain English. And then we're going to put these parentheses here. You'll notice that I leave them empty. I'm not putting anything in there. And we'll touch a little bit on that later. So def, the name of the function, these opening and closing parentheses, and then my colon. And at this point, you guys probably are aware that once we press enter, we get tabbed in underneath the definition of our print name function. So cool. Let's go over what this looks like. We're basically telling Python, hey, define a function. It is called print name. Print name. Here is what it does. That here is what it does is sort of what this colon represents, right? Because once we tab underneath that, we can start talking about what the program will actually, or sorry, what the function will do. So as the name implies, print name, all it's going to do is just say print, my name is Varun Patel. That's it. Okay, so I'm going to clear my output, and I'm going to run this. And nothing happens. Nothing comes out to my console. Why is that? Well, I've defined the function, right? This whole little chunk of code I've highlighted here, that's defining the function. But I never called it, right? You notice that with our int functions, we have to sort of, or int or the functions that we have rather, we have to call them like this. It's not like we're saying def int. So we're just going to say print name, and we're going to have those parentheses. Now, what do you guys think that this sort of line of code is going to do? Right? I've defined the variable, and then from here, now that I've called this function, what is going to happen? What is going to be the output of the code that I have so far? Yeah, Maria is correct. All it's going to do is just going to print out my name. So let's run this. My name is Varun Patel. Okay, so we have our definition. We call it, and when we call our function, it's going to do everything that happens that our function has been defined to do. So cool. Every time we call it, it does this. So what happens if I do this? Right? If I call this print name function 3 times. Someone tell me what this would do. What would be the output of this to my console then? We know that one print name function prints my name out to the console. What would 3 of them do right after each other? I think there might be a little bit of lag on my end because, again, hotel Wi-Fi. So if you've put anything in chat, I can't really see it right now. But I'm going to assume that you guys said that it's just going to print out "My name is Rune Patel" 3 times to the console. And that is exactly what it does. It just prints it just like that. So we can see that by just calling this print name function once, we're able to execute this block of code. And so let's assume what this could mean on a bigger scale. So let's say we wanted to run several lines of code. In that case, we could just have this print function and a lot more things. And then we could just reuse this function over and over and over. So the idea of having functions is super strong, and knowing how to use functions is super strong because it allows you to write code that is cleaner, and it ensures that you don't have to repeat yourself every time you write your code. So now let's try to make our functions more dynamic, right? Let's try to add some extra things to them. This is our general sort of thing with our function. So let's go back upon what we know. With our int function, for example, right? We give it an input. However, when I ran over this sort of execution of a function, when I call this function here, you'll notice that I didn't have to give it anything. And that's because when I define my function right here, I defined it not to take any arguments, not to take any input. And that's why the space between these these parentheses is empty. So how do we allow ourselves to create a function that can take input from the user and then produce us a different output for every input that they give us? So now we're going to talk about the idea of parameters and arguments. So again, what we're going to do now is we're basically going to create a function that takes 2 numbers, and it's going to tell me which number is bigger. That's basically what it's going to do. So we're going to say create a function that takes 2 numbers and then prints out which number is bigger. So let's do what we know. The first thing we need to do is define this function. So how do we do that? We use our def keyword, right? Stands for define. Now we have to give a name to our function. So let's sort of think about what this function is doing. It's taking 2 numbers and it's going to print out which number is bigger. So maybe we could call it something like biggest number, right? And then we have those parentheses, and then we have our colon. We have whatever our function will do. So now let's try to figure out how do we implement the idea of arguments and parameters within this function. So we want our function to take 2 numbers, right? A first number and a second number. And those are the different arguments that we can give it. So we can say that our biggest number will take a first number and a second number. They're sort of like the names that we're giving to our arguments. So now let's go ahead and see how we can use this, use our sort of arguments and use these definitions for them. So essentially what we've done is we've created 2 variables that we can reference within the scope of our function. So the first thing we're going to do is let's just assume we have random numbers. Right? Let's just give them random values so that it's easier for us to visualize how to use them. Let's say that our first number is 10, and then our second number is 5. We know that between both of these numbers, 10 is bigger, right? Our first number is bigger than our second number. So let's implement that logic, and let's use some of our if statements to come to that. So we'll say if our first number is bigger than our second number, it's going to print our blank is the biggest number, period. And we have to sort of put in that first number is going to be the biggest number. So let's turn that into an F string. And in our brackets, we're going to put first number. So if first number is bigger than whatever second number is, our code is going to say, hey, first number is the biggest number. If this doesn't become true, right? Let's say second number is smaller, or sorry, second number is bigger than the first number, then what we can do is you can use an else statement. And we can copy this, and we can paste that, we can put second number. Why am I using this else instead of stating it explicitly of saying second number greater than first number? Well, if first number is not greater than second number, then that automatically means that second number is the biggest number between the two. So this may seem a little bit confusing right now because I've sort of magically conjured these two variables right here. So now, if I run this, you'll see I don't get any errors, but nothing happens, right? Nothing happens because I'm not actually calling the function. But we're not getting any errors because there's nothing wrong with how we've defined our function in the first place. So you see that we get nothing. It comes out to be blank. So now, let's actually call this function. We're going to say biggest number, right? Because that's how we call our function. And then we have those parentheses. So we know that our function takes two numbers. It takes a first number and a second number. So let's go back to sort of the numbers that we were assuming we were using. We were using 10 and 5. So we're sort of saying that 10, since it's the first thing we've passed, and first number is the first sort of parameter that we've created with the definition of our function, what we're saying is that whenever we run this function, right, we're going to execute this block of code. And when that block of code executes, we're basically saying that for everywhere there's a first number, there's a 10. And everywhere there is a second number, there is a 5. That's sort of the logic that's being there. So these are sort of placeholders. And as soon as we give those arguments, right, as soon as we give the 10 and the 5, they then take the place that those placeholders are holding for them. So if I run this, you'll see that it says 10 is the biggest number. So let's create another example. This time, we'll say we'll have 30 and we'll have 40. And this time, it should say that 40 is the biggest number, right? It's our second number. And since our first number, our 30, is not greater than 40, it'll automatically default to this sort of else statement. And when this runs, you'll see that 40 is the biggest number. So is everyone sort of okay with what I've talked about here? And I'll explain a little bit more, but I just want to make sure that everyone is following along with, first of all, the function declaration, or definition rather, and how I've used these sort of variable names as placeholders. And as soon as I then call this function, right, as soon as I actually give those placeholders legitimate values, then it's able to actually run and produce an output. So is everyone sort of okay with that? Okay, looks like everyone's okay with that. So, okay, so I've created this function, right? I'm just going to reiterate what I've done. I've created a function that has these placeholders for a first number and a second number. Whenever I call this function, I give it these two values. So what happens if, say, for example, I don't give it that value? Or instead of giving it two values, I only give it one value. Say I'm missing out on something. So we know that both of these examples here work, so I'm just going to leave them there. Now I'm going to call this function again, but I'm not going to pass it any arguments. I'm going to leave it completely blank. And let's see what happens here. So we get an error. So we know that the first two worked, right? We get the output that we wanted. But when we run this, right, line 16, that's where error is, line 16, that's what we're looking. We see that when we have this, we get a type error. And it's saying, hey, whenever you call this biggest number function, right, you missed two arguments that you had to give it. You didn't define what first number was, and you didn't define what second number was. And since you didn't define them, I can't run this code. How can you assume that first number is greater than second number if you don't even know what those values are? If there's no way to tell, what they are. Okay, so that's what happens if we don't give it both values. What happens if we only give it one value, right? Let's say I only define first number. I only give it that 20. If I run this, I get another error. And this is just like the same thing we got with the first one, right? Line 16, that's where we're looking. And this is what we've written, right? You're getting a type error. You're missing one positional argument, second number. So you're missing the second number. You've passed in the first number, but the second number is not there. So again, this code can't run. How can you say that 20 is greater than second number if you don't even know what second number is? Second number could be 1. Second number could be 40. And so unless you define them, there's no way for that code to run and give you the output that it should. So that's what happens if you don't give it the correct number of arguments, if you don't fill those sort of spots. Now let's see what happens if, say, for example, we want there to be a default value. If, let's say, I'm going to get rid of this now. That's our sort of example for using arguments. And actually, before I want to continue, I do want to clear up some terminology. So within the definition, right, because I told you guys we're going to work with parameters and arguments, but I never really made that clear. But in our definition of our function, right, we've created these placeholders, right? First number, second number, they're all placeholders for values that we give it later on. And so in that case, these sort of placeholders are called parameters. They don't have specific values, right? But essentially, they're placeholders in the definition of your function so that when you call your function later on and you give it those values, Python knows where to put the specific values. So when you call biggest number here, give it that 10 and that 5, Python says, okay, so I now know that this first number placeholder has the value of 10. And I know that this second number placeholder has the value of 5. So in your definition, you have parameters, placeholders, if you will. When you call your function, right, when you actually start giving values to those parameters, these are called arguments. So one more time, parameters are within the definition of your function, and they're sort of like placeholders. Arguments are the actual values that you end up giving to your function when you call it. So that's how you should, that's terminology that you guys should know. And so that's how that terminology plays into what we've done. Cool. Let's move on with our next example. So we're going to create a function that's going to take a name, and print that name out to the console. So pretty straightforward, pretty much what we did with our first sort of practice function, but I'm going to add a little bit something unique to it. I'm going to say if there is no argument given, if you remember, arguments are the values that we give our function. If we don't give it an argument given, we're going to default the function to printing just my name. My name isn't like Varun Patel. Oh, let's do what we know. We're going to create a function, and we're going to have it just print out a name with an argument. So we're going to say def print name, just like last time. And we know that this function has to print out the name that is given to it, right? So it's going to have to take in a value. That means we need to have a placeholder somewhere. And since we're taking a name, we're just going to say username. Actually, we'll just call it name rather. Right? So we know our function, we're defining a function, and it's going to have a placeholder somewhere in the code called name. How are we going to use this placeholder? Well, we're just going to say print your name is, we have a little blank here. We're going to format this. Oops. Format that. And then we're going to print out with that name. So we're given, this is our placeholder, right? This name right here and here, they're placeholders. So when I give it, or parameters too, right? There's the parameters right there. So when I call this function, I give it the argument, print name, and I'll just say Varun Patel. We should hopefully see your name is Varun Patel, right? And if I take this function, I call it again, but this time I give it a different argument. We'll say David Jones, or random name, or whatever. We see we get your name is David Jones. And you can assume that if I call this again and again with different names, you get, your name is whatever the name is that's given. So we know everything right now is working. So we've sort of covered this first part of our prompt. The second part of the prompt that we need to touch upon is, what if there is no argument given? Well, let's see what happens if we don't give it an argument. All right, let's see what happens if I leave that blank. Well, as you guys can probably assume, we get an error. And it's the same error we got with our biggest number function. That error being a type error, because we're not giving it a required positional argument. We're not specifying what this name placeholder should actually be. So now we're going to touch upon something called a default, or sort of like a default parameter. And what this says is, if I don't give a value for, let's say, the name parameter, then Python has the ability to default, right, to fall upon this value that it'll use. And in order to specify default, all you have to do is come here and say name is equal to whatever you want that default value to be. So I'll say Varun Patel. So let's run this again with what we knew worked. So let's say we have David Jones. That still works. And you see your name is David Jones. We're giving it this input, and it's able to print that out. But again, what happens if I don't give it that input? No argument given. Default to printing my name. So that means we're going to fall upon this default that we specified. So print name, no arguments given, right? When I do this now, it should say your name is Varun Patel. So how is Python, okay, before Python wasn't able to, print out when there was no arguments, because it's unable to say whatever this name placeholder should be. But now, since I specified this, right, so it's sort of like saying the name variable is equal to this, and then you use that variable within the scope of your code. Now that I've specified this, it's able to say, okay, well, here they gave us an argument of David Jones. This time they didn't, but not to fret, because they still specified a value that I could default back to. So now let's go and fall back to that biggest number function. I'm just going to control Z all the way to that. There we go. And now let's sort of create our defaults here. So I'm just going to create defaults for both the numbers, where we say first number is equal to 10 and second number is equal to 5. That's how easy it is to create the default. Actually, let's change this to like 15 and 6. Both of these will still work, right? We'll see 15 is bigger and 40 is the biggest number. But if I call this now biggest number with no arguments, I'm not giving it anything, can one of you guys tell me what you think would happen in that case? We're assuming that first number is 10 and that second number is 5. These are the default values that it will fall back upon. So if that is the case, what would then be the output of whatever I've written here on line 16? Yeah, it'll print out that 10 is the biggest number. Perfect. And let's run that. We'll make sure. And yeah, 10 is the biggest number. So what have we done so far? All right, let's get a little bit of a review before we continue, because we have like 40 minutes left. We have plenty of time to keep going. So we have talked about defining a function, right? How do we do that? We've defined a function that takes no arguments. We've defined a function that takes multiple arguments, right, like this. And we've seen that if we create a function that takes multiple arguments and we don't give values for all of those, parameters, then our code won't work. We'll get an error. How do we get around this? Well, in cases where it's appropriate, right? It's not always appropriate to sort of specify, defaults. But in cases where it's appropriate, you can specify a default value that the Python will fall back upon in case there are no arguments given. So that's what we've touched upon there. And to wrap up our review, and I think we've sort of just done lesson 4 all over again, but a little bit faster. But to wrap up our review of lesson 4, the last thing I want to talk to you guys about, and this for sure I do recommend you guys go back to lesson 4 and check out, because I'm sure I explained it better there, because I don't really have the time right now. We talked about something called a return statement. And I'll go over this very briefly, and we'll actually use it in some of the practice that we're going to do today, because I think that's going to take up most of the time we have left. But the return statement. So let's touch back upon what we did, I think like lesson 2 or lesson 1. And with that, we assumed, right, we had like an age, and we said age was 15, or 17 rather. And what we wanted to do is we wanted to print out the value of age plus 1, right? We wanted to get 18. We wanted to do 17 plus 1. And basically, we got an error with this. Why? Because age is a string, right? Because we know that because of that double or that single quotes, again, personal preference. Age is equal to 17. That's a string. This plus 1, that is a integer. So it's basically like, let's take a sentence, if you will, and add a number to it. It just doesn't really work out like that. How did we get around this? Well, we had an option. We could either kill these double quotes, right? And then that would work. Why would that work? Well, because both of these things are now integers, right? And it makes sense to be able to add 17 as a number to 1 as a number. Let's say we wanted to keep the double quotes. We also had the option to basically wrap this within a int function, right? We could put this within an int function. And we could put it here, or we could put it here. It really wouldn't make a difference. But let's say we put it right here, right? We said age is equal to int 17. That works out just fine. And basically what this is doing, right, is we have age is then equal to 17. So this sort of expression right here, this whole thing simplifies to 17 as an integer. So basically what it looks like we're doing is we have a function, right? This is just a normal function call, but then we're setting it equal to a variable. We're saying that age is equal to this function with the given input of 17. So it's sort of like this function, right? It does what it has to do, and as soon as it's done converting our 17 as a string to an integer, it poops out this value of 17. And this makes more sense. So it's sort of like our function, after it's done running, gives us a value. We take a value from it. Okay, so it's sort of like returning a value for us to actually use later on in our code. So in order to sort of illustrate the usage of a return statement, to illustrate why we have return statements, let's actually create a function that's similar to something you'd see in math. Right, so we're going to create a function called f, and it's going to take in x. So just f of x. And we'll create a linear sort of expression. We'll say f of x is equal to 2x plus 1. Basically, what we want to do here is we have a function called f. We're going to give our f function a random number. We'll give it 1, for example, right? It's going to take that 1, it's going to do 2 times 1, and that's going to add 1 to that. So we're just creating a normal function. So in math, you would see this sort of like f of x is equal to 2x plus 1. That's sort of what we define in terms of programming. So now let's call this function. We'll use different inputs. We'll say f of 1, f of 2, f of 3. Oops, f of 3. If we run these now, we have 3, 5, 7. And if this example isn't a good example, just let me know. I just thought it would make more sense to have this sort of thing in the scope of mathematics. Um, but these are just our mathematical operators. These are all things that we've touched upon anyway. So anyway, I've specified our function. I've given it, something to, do the math, right? We're taking whatever our value is, we're going to multiply it by 2, and then we're going to add 1 to it, and we're going to print that out to our console. Let's say I wanted to save the value, right? I wanted to create a variable called, random. That's not a good name. We'll just call it num, right? We want it to be the output of f of 4, right? That's what we want to do. And that's something that we've seen before, right? We've had age is equal to the int of 17. There's really nothing different between the two of them. We're basically doing the same thing. So we're saying that num is equal to whatever f of 4 is. And we know, but if we do a little bit of math, we can tell that if we give this number of 4, right, 2 times 4 is 8. 8 plus 1 is 9. So when we print out num, we should hopefully get 9, right? No, we don't get anything. We get none. But we still get this 9 right here. So it's like, what's going on? Well, you'll notice that whenever I call f of 4, it's always printing something out, right? So that's why we have this 9 here. That's being printed out to the console. But when I print out num, I get nothing. That's because my function is not actually giving something. It's not returning anything to be saved to a variable or anything else like that. And that's where we have the return keyword. So what we're going to do here is we're actually going to cut this right here. We're going to kill this print statement. And we're just going to do this. That looks completely different from what we had before. So now we're saying, hey, define a function called f that has the placeholder that takes an argument to fill the parameter of x. And then I want this function to return whatever 2 times x plus 1 is. So now if I run this, I only get 9. That's because whatever I had with f of 4, since it's being returned, it's basically simplifying out to this. Right? Does that sort of make sense how this return statement works? And I don't think we're going to use it with the practice that I have in mind with this lesson, but I just want to hear from you guys if there's something I want to go over with more practice. I'm actually having some issues with my connectivity. I'm a bit confused with this. Okay. So let me go over what I did one more time. And I'm actually going to create 2 functions. We'll create an f of x, and we'll just create a h of x, right? One of them will return 2 times x plus 1. The other one will print it out, right? So the whole thing with them is that the math is all the same, right? The only thing is f of x will print that out to the console, and that's something that we shouldn't be too confused with, right? That makes sense. H of x, on the other hand, will return it. So think of returning with the idea that whenever I call this function, a function has the ability to sort of hand over a value that can be used later on in the code. So if I do, we'll create 2 variables. Say one is r, the other one is d. And r will be whatever f of 4 returns, and d will be whatever h of 4 returns. This makes sense so far, what I have right here. Okay, that makes sense. And I'm sorry, I have a really bad delay because this network is just terrible. Anyway, So this makes sense. So let's explore what both of these variables will give us. If I print out R and I print out D, oops, what happens? I get 9, none, 9. So let's work our way from the top to the bottom. These two things should make sense up until this return statement. But for the most part, these are just definitions, right? Nothing's happening in them until we call them. So let's go to the first time we call our first thing. So we're saying R is equal to f of 4. So what happens when you do f of 4? Well, you're giving that 4 for this x value, right? So basically, we're just going to print out 2 times 4 plus 1. And that's where we get this first 9 from. And then we have D is equal to H of 4. And you realize that nothing gets printed from this, right? There's nothing that comes after this. However, when I print my R and my D, I get this none and this 9. So why is it that when I print R, I get none? But when I print D, I get 9. That's the value I want D to have in the first place. That's because I'm not telling my function to actually give something. Think of it in terms of I have a function. That function then has the ability to give a value to, say, a variable. Because I haven't defined a return statement, my f of 4 isn't actually giving anything. It's giving nothing to this R variable. And that's why when I print out R, there's nothing in it. None. However, with my H of 4, I've specified that it's going to return whatever 2 times x plus 1 is. So in this case, it's 2 times 4, 8, plus 1, 9. So it's going to give that value of 9, right? And then D, when I print out D, I get 9. So that's that. I actually don't want to go over this a little bit. I want to save this for a little bit later, um, later on when we do other projects with this. But it's just something I want you guys to have, in the back of your mind to know about syntactically. And if you do get time to sort of try to get some practice with, read up about it. So that's sort of everything we went over in lesson 4. And it seems like lesson 5 has become basically lesson 4. So we have 30 minutes. I want to hear from you guys because there's really 2 options. Do we want to do more practice with loops and functions, or do we want to move on to what I have had planned at least for this lesson? Because I don't mind doing either or, because I have, we could create like a guessing game. We can make like a random number thing, and we can get some practice with some functions as well. So I have a bunch of ideas for practice we can do with loops and functions. But if you guys are confident with how you're feeling with these, we can move on to talking about lists. Okay, I'm hearing more practice with loops and functions. And again, I apologize for having to switch between my tabs like this. My network is abysmal right now. So let's get some practice. We'll do practice with loops and functions. Functions. Yeah. Okay. The first thing we're going to do is we're going to do a guessing game. Guessing game. And what that means is we're going to use a while loop, right? We're going to allow the user, actually, we're not going to use a while loop, we're going to use a for loop. Allow the user 5 chances to guess a random number between 0 and 20. Okay? And right now, we're actually going to specify that a random number right now. So we're just going to say a random number is equal to, let's say, 13. And I'll let you guys know that later on, I'll talk about how we can generate like actually random numbers. You don't have to specify it. Every time you run it, you get a different random number. So we've specified what our random number is. Now we want to give the user 5 chances to guess the random number. So the first thing we're going to do is we're going to create a for loop, right? 5 chances. That's an easy way to define it. So for I in range 5, right? We want this to run 5 times. And if I print that I out, you'll see we go through it 5 times. We go 1, 2, 3, 4, 5. So this loop runs for 5 times. So the first thing we need to do is ask the user what they think the number is. So user guess is equal to the input. What do you think the number is? Question mark. And let's just make sure it's working. It should ask us this 5 times and then print out what we type in 5 times. What do you think the number is? I'll say 10, 11, 12, 13, 14, 15. Yeah. Don't mind this 15 down here. I got a little carried away, but 1, 2, 3, 4, 5. It ran for 5 times. So we know that this whole for loop is working right now. Cool. The next thing we have to do is just check to see if our user guess is equal to our random number, then we're going to print you guessed the correct number. If that's not the case, else print incorrect guess. Try again. So let's run this. We know that the random number is 13. So let's just go ahead and we'll just type in 13. See, we get incorrect guess. That is so weird. We typed in 13 and we know that the random number is 13. So what is wrong? Well, it's this input function. Because you remember, it's giving us a string. So we need to make sure we turn that into an integer. Because it's basically saying, is this string equivalent to this integer? No. So we have to turn it to an integer in the first place. Let's restart that. And let's run this again. What do you think the number is? If I type in 13, you guess the correct number. But for some reason, we're still going through this loop. If I keep typing 13, which we know is the correct answer, it goes up until 5 times. But we know that it has to break out of this loop, right? We don't want this to keep asking us even after we've guessed it. So we're going to use this break keyword. And if you guys remember, we use this break keyword to sort of exit out of a loop prematurely if a certain condition is met. So let's run this, and I'll show you what I mean by that. And we'll go through this step by step. So it's asking us, what do you think the number is? So we're right here. I'm going to type in, let me zoom out a little bit so it all fits on the screen better. What do you think the number is? I'll say 11, right? So let's check. Is my user guess equal to my random number? It's not. So then it's going to print incorrect guess. That makes sense. Let me do that again. Let's put 12. Yeah, looks like my thing reset. Let me try that again. So we had 11. That didn't work. Let's try 12. That also didn't work. And that makes sense, right? So what can we do here? If we type in 13, all of a sudden, it works. And the game exits, right? It doesn't keep going. So we're on our third turn in the for loop, right? We've used our first one, our second one. We're in our third turn. Is my user guess equal to my random number? Yes, it is. Okay, well, it's going to print out, hey, you guessed the correct number. And then this break says, okay, well, I'm still in the middle of this loop, right? I'm on my third turn out of all the 5 turns that I can have. I'm going to exit this loop right now, though. And it breaks out of the loop. So if I keep going and I just keep typing wrong answers, right? 10, 11, 13. Oh, shoot. 10, 11, 12, 14, 15. You see that the output is what we want it to be. However, if I type in 13, it exits out in the first time. So that break keyword allows us to leave, let me comment that, allows us to leave the for loop prematurely. So does that sort of make sense? That's our sort of practice with our for loops. Is everyone okay with that? Should we not have the range up to 20? Maria asked, should we not have the range up to 20? So I think she's talking, yeah. Okay. So I think what you might be asking about is this, right? So let's go over what this code is doing again. This is our random number, right? And it's a random number between 0 and 20. That's sort of just a general rule I've set for this program that we're writing. This for loop is actually sort of like the number of tries that we're giving the user. We're only giving the user 5 tries. Remember, if we set this range up to being 20 and run this, we're basically giving the user 20 tries. So I'm just going to keep going. It's 20 tries that we're giving the user. So this for loop is not for the purpose of generating a series of numbers between 0 and 20, but rather it's about giving the user 5 opportunities, right? 5 opportunities to do the same thing, to guess, to check the guess, and to start again if they have to. So this is sort of like the first time that we're using for loops, not to generate a sequence of numbers, but to sort of repeat a set of code a specific amount of time. Does that make sense, Maria? Like what I sort of went over there? Again, not trying to generate numbers from 0 to 20, but to generate opportunities for the user to actually, guess the number. Okay, perfect. Cool. So that was our loops practice. That's really the only practice I want to do with loops because we have talked about them a lot. So now let's move on to doing function practice. And this I have a lot of stuff for. And we have 19 minutes left, so I think we'll have a good amount of time to go over it. Function practice. Cool. We're going to create a function. Create a function that takes a number from the user and then uses a for loop to print out the Fibonacci series up to that point. Okay, so this is some big stuff that we're doing here now. This is definitely like combining a bunch of elements of what we're doing. So I said function practice, but we're also using a for loop. So create a function that takes a number from the user. So we're going to have to give input from the user. And then we're going to use a for loop to print out the Fibonacci series up to that point. And this might seem a little bit weird right now. So let me talk about what the Fibonacci series is. And I guess this has turned into a little bit of a math conversation. But basically, the Fibonacci series is, I'm going to just write it out real quick. What it is. 34. Okay, so basically with the Fibonacci series, this is what it looks like. And it goes so on and so forth. What am I doing here? What is the sort of pattern that we're working with? So the pattern that we're working with, actually, let's not do this. I just realized this is way too confusing. I apologize. Yeah, this is not a good example, actually. Restart with the function practice. We're going to instead create, because I realize it's not really function practice if we're just working with loops and we're doing math stuff that I don't have any good way to like demonstrate and draw out. So let's not do that. Let's create a function instead that makes sure that the user is giving proper input. And what do I mean by proper input? Well, let's think about it. In all of the programs that we've created, because we've made them, we've been able to give them like the proper input. So if you remember correctly, with, let's say we had like an age function, right? And we were trying to find out what the age was in 100 years, or how long until we were 100. what happens if instead of giving like an integer into that function, we give it a name or a string or a float? That would break our code. So what we're using this as an opportunity to do is create a function that makes sure that the user is giving input that is valid, input that won't break our code. Because think about it, with all the coding that we've done, with all the projects that we've done, we have created a perfect system where we're the people giving the input. But what happens if, say, we wanted to share our code with someone and they don't know how it works and they gave like the wrong input? We have no way for checking that. And that would then lead to our code breaking. So let's just do an example that we should be pretty familiar with. We're going to create a function and we're going to call it sum to 100. And we've done this before. This is basically taking all the numbers from 0 to 100 and then adding all them up. So we're going to create this as a function. If you remember how we did it last time, we had that sum, right? We had our for loop for I in range 101 because we're going from 0 to 100. You don't have to specify the start. We're stepping by one, so you don't have to specify that either. So all you have to do is specify the end. So since we're going to 100 all the way up to, but not including 101. So for I in range 101, we're going to take our sum and we're going to add that I value to it. And this should be pretty straightforward. That should make sense right now. And then we're just going to go ahead and print out that sum. So if we call our sum to 100, we should get 50/50. Straightforward. We already know how this works, right? We're just combining two elements of what we've worked with. We have our loops and we have our functions, nothing crazy. So with this, let's try to jazz it up, right? Let's do sum to n, sum to a value that the user gives us. We're going to copy this or paste that. We're going to create a function that's very similar to this, but it allows us the user to give input. It allows the user up to what number we add to, right? Let's say we want to add all the way up to 20 or to 30, right? So we'll call it sum to n. We'll say that n sort of like a placeholder. So we'll say user number. And then this will say for I in range user number. But nothing crazy. Again, so if we do sum to n, give it 101, that should give us the same output that we got right here, right? Because we're just doing all the numbers up until, but not including 101. And that works out just fine. But now, since we've allowed it to take an argument, right? Since we have that parameter in there, we can give it whatever value we want to. It could be 20, right? That'll give it all the numbers from 0 to 19. It can be 86. Oops. Sum to n 86. That should give us all the numbers from 0 to 85. If we run that, we get a different output for all of them. So it's a flexible way of writing our code. Okay. Well, what happens if I give it something like sum to n from 0 to -1? How do you do that? That doesn't work. We don't get anything from that. We get 0 because our sum was always 0. So if we run this with a bunch of bad input, right, then it won't work. So let's create a function that takes what the user is given, right, that user number, and then checks to see if it's actually a valid number that is, greater than or equal to 0. So now let's say another function, let's say def, and let's call it input checker. And this is also going to take the user number. Does this make sense so far, what I have written out and what I'm trying to get this code to do at least? Okay, looks like everyone's okay with it so far. I'm not seeing anything on my end. So let's go ahead and continue with this. Input checker. So what do we want our input checker to do? We want to check to make sure that the number our user gives is greater than 0, right? So we want to say that if our user number is greater than 0, then we're going to say, hey, that is a valid number. If it's not greater than 0, that means it's either 0 or less than 0. That means we can fall upon our else statement to say that is not a valid number. And let's just ignore the sum to n right now. And let's just make sure our input checker right here is working. Input checker. Let's give it a couple different scenarios. We'll give a value that's greater than 0, so let's say 10. And then we're going to give it a value that is 0. So input checker, we'll say 0. And then we'll give it a value that's less than 0. So input checker, and we'll say -10, right? So we have a value that's greater than 0, a value that's 0, and a value that is less than 0. So let's run this and see what we get. So we get that is a valid number, that is not a valid number, and then that is not a valid number. So this is valid, this is not valid, and this is not valid, right? And that makes sense, right? Because we want the numbers that are greater than 0 to be the numbers that our code actually uses. So we know our input checker is working. So how do we sort of tie both of our functions together? We have two functions. They're independent of each other right now. So how do we get them to speak to each other, right? So the first thing we want to do is our sum to n is sort of like the main thing that's happening, right? So our input checker, we're going to use a function within another function, if that makes sense. So let's actually change this from print statements to return statements. We'll get some practice with this. And it might be a little confusing right now, but just bear with me for a second. Okay, so what I've done here is instead of just printing out if it's valid or not valid, I want the functions to be able to speak to each other. What is the best way for a value to be carried on to something? That's the return keyword, right? That means whatever happens with this input checker, I can save that to something in my sum to n function and then check to see if my input was actually valid or not. And again, this is going to be a little bit confusing, so just bear with me here. So our sum to n, we take our user input, and now we want to see if that input is valid. Is valid input, right? And then we're going to set that equal to input checker with the user number. And if valid input, if this is valid input function, sorry, variable right here, is valid input is equal to valid, and we're going to go ahead and run this whole snippet of code. Else, it's going to say print this is not a valid number. So let me go ahead and run this real quick, just to demonstrate that it works. And then we'll go back and I'll go through every single line of code. So I'm actually going to call this sum to n, right, because we have to call the function. And we're going to do the same thing we did last time. We're going to give it a value that's greater than 0, a value that is 0, and then a value that is less than 0. Make this 0. I'll make this -10. If I run this, I get 45. This is not a valid number. This is not a valid number. So it's working, right? Now let me actually go over, because I did a lot there. Let me go over what I've done. Just to reiterate, I have two functions, right? One function is used to check the input to make sure it's good input. And then the other one actually does all the math and computational stuff. The main problem I was having was there's no way for them to speak to each other, right? To work in tandem. So I decided to say, hey, this input checker will have the ability to return values, to return if it's valid or if it's not valid. Why am I using return? Well, this return thing, as I said before, allows you to have a function, and every time you call that function with the appropriate arguments and whatnot, it's able to give a value that can later be referenced. So that's why when I say is valid input, basically this input checker is taking this username right here, or user number, and then it's going to do its own thing. It's going to check, is that greater than 0? If it's not, it's going to say valid. If it isn't, then it's going to say not valid. So when it returns this value, this sort of thing either becomes valid or not valid. That's sort of what it breaks down into, or what it becomes after it's sort of evaluated everything. So after that, it then says, okay, if this variable is valid, then I'm going to go ahead and do all that summing up. That's just the normal for loop that we've referenced and used and love, and we've used that before. But if for some reason it's not valid, right, then this won't happen. It's going to default to this else, and it's going to say that is not a valid number. So that's sort of how that works. And this is actually, we only have 4 minutes left. So any questions about what I've done here? Would you like me to go over, what I've touched upon? I'm more than happy to go over time. I don't really care. I just want to make sure that you guys are actually understanding what's going on. Sorry, I'm just double checking on both things because I don't know which one is loaded and which one isn't. Okay, Maria's okay, Zane is okay. Awesome. I'm actually really glad that you guys followed along with that. Yeah, that's actually the last thing I want to touch upon. If you do get some time, I do hope you guys go back and look at lesson 4, because it's just the same thing we covered today. We actually didn't get to any of the lists and stuff like that. And I do have a couple other things I wanted to practice with, loops and functions, but we'll save that in case anyone needs to do it later on. So thank you guys for a wonderful stream. And I do apologize that there may have been some issues with my connectivity, with my microphone, with noise outside. So I thank you guys for bearing with me here on vacation. Again, the camera angle, everything's a little bit different. I had to switch tabs and all that stuff. So thank you guys for bearing with me. And I hope that this lesson was good and there were no connectivity issues. Again, if you have any questions, you can head over to my teach.tv profile page. All my associated links and all that stuff, that's all there. And you can reach out to me through that. And I don't think we have any more questions. Yeah, everyone seems fine. And yeah, I love teaching, guys. This is fun. Vacation's fun. I'm just enjoying myself right now. So I believe the next lesson will have to be recorded, unfortunately. But it's okay because I recorded the last lesson and I was more than happy to go over it in this live stream. So it'll probably just be like that. Think of it as just something you can reference later. So, thank you guys so much for another great stream. I hope you guys are all having a great day and, your day continues to be good. Be sure to take care of yourself. Be sure to practice, because that's really what's going to make you better at what you're doing. And make sure you tie in everything that we use from lesson 1 all the way to lesson 5. And so, yeah, I'll see you guys in the next stream. Thank you so much.